In this video, we are going to solve the 2004 Form B question number 4 FRQ. So it says the figure above shows the graph of f prime, the derivative of function f on the closed interval x is between -1 and 5. The graph of f prime has horizontal tangents at 1 and 3 and is twice differentiable with f of 2 equaling 6. Okay. So let me underline these two key parts. Find the x-coordinate of each of the points of inflection of the graph of f. So we have f prime, which is first derivative. We need to find where the slope changes. We would say x equals 1 is a point of inflection because f prime of x is greater than 0, then f prime of x is less than 0. The next point of inflection would be at 3, and that's going to be the last one. So x equals 3 is a point of inflection because f prime of x is less than 0. Let me zoom out. Then f prime of x is greater than 0. And x also f prime of x equals 0 for both of these parts. I should probably write that down. F prime of 1 equals 0. And f prime of 3 also equals 0. Okay, so now the next part says B. At what value of x does f obtain an absolute minimum? On the closed interval -1, x, which is less than or equal to 5, at what value of f does it obtain an absolute maximum value? For x is between -1 and 5 on the closed interval. Show the analysis that leads your answer. Okay, so the minimum is really easy to do. The minimum is going to be at f prime of 4, or f of 4. And the reason is, you would say -1 less than or equal to x, which is less than or equal to 4. F prime of x is decreasing everywhere. And then from 4 is less than or equal to x, which is less than or equal to 5. F prime of x is increasing. Okay, so now we can now say f of 4 is a minimum because there is only one sign change from negative to positive at x equals 4. Okay, so the next part, the max. The max has to be an endpoint now. So the endpoints are going to be, well, let's look over here. Let's look at this graph. It has to be an endpoint. So let's look over here from -1. That's a ton of negative area. And now let's look, let me change color so we could kind of see. Okay, and if you look over here, this is a little bit of positive area. So now we would say from -1 to 5, f prime of x dx is less than 0. And now we could say f of 5 minus f of -1 is less than 0. So now we can manipulate this and say f of 5 is less than f of negative 1 So based on this analysis, we see f of negative 1 is greater than f of 5. So therefore, f of negative 1 is the absolute max. Okay, last part. Let g be the function defined by g of x equals x f of x. Find an equation for the line tangent to the graph g at x equals 2. Okay, let me move this around so I have a little bit of room. Okay, so pretty easy. Let me zoom in. Okay, well, we don't need the whole entire graph. I just need this piece right here. Okay, so, oh, and I do need the piece f of 2 equals 6. Okay, so for part C, we have g of x equals x f of x. So we have the point f of 2 equals 6. We need a tangent line, so we need to find m. What does m equal? So we need the slope. So g prime of x is going to equal 1 f of x plus x times f prime of x. And now we got to plug in the 2. So f of 2, 1 f of 2 equals plus 2 times f prime of 2. So we're going to have to go back to our graph. 1 f of 2 is 6 plus 2 times, let me look at the graph, f prime of 2. F prime of 2 is negative 1. We could see it right here. Let me get rid of this little thing so we could see it's negative 1. Okay, let me go back. So we said that was negative 1. So m is going to equal 6 minus 2, which equals 4. So now we could write our equation y minus 6 equals 4 parentheses x minus 2. So we're going to get y equals 4x minus 8 plus 6, which equals y equals 4x minus 2. And that is a line tangent. And I hope this video helped.